I'm Brian Boyer. This is part 2 of my paper on Google Flu Trends. We will now examine the GFT interface. This is the GFT Web Tools interface. The world map provides near real-time estimates of flu activity for various countries and regions based on aggregated search queries. Flu activity levels for these regions are reported as minimal, low, moderate, high, or intense, and these levels are color-coded according to the flu activity legend on the left of the interface. General activity levels for each region are based on a comparison of search data compared against a historic baseline of influenza activity for that area. Hence, the lime-green color of the United States indicates that aggregated search data for influenza-related queries suggest a minimal level of influenza when compared to the historic baseline. Specific regions or countries can be examined by using the pull-down menu on the upper left-hand corner of the interface. For example, selecting the United States provides a map of the United States with estimates of influenza activity levels for each state. Note that influenza activity can be accessed for particular cities and is labeled experimental. Areas labeled experimental have not been formally compared with official influenza data for that area. After selecting cities, clicking on the marker for Greensboro, North Carolina reveals that this city is experiencing a low level of flu activity. The graph above the map of flu activity compares the official flu data for the selected area with the aggregated Google search data represented at the bottom of the graph. Thus, flu activity estimated from aggregate query data from the Greensboro area can be compared to levels of flu activity indicated by official surveillance data for Greensboro. Official data for influenza activity is provided from 2004 to the current month and year. Individual years can be selected to be compared to estimated flu activity from GFT as well. Here is a comparison of official influenza data with estimates from GFT for 2007 to 2008 for the United States. Note that the levels of influenza activity for the official reporting and the estimated flu activity from GFT are comparable. The Download World Flu Activity data function allows for the downloading of the GFT weekly influenza estimates for the world. The data must be downloaded in comma-separated values in a .csv file and imported into a database or spreadsheet program. The downloaded data is in fixed mode, which means that the data are normalized using the extrapolated search volume at the start of GFT data, which is January 2004. This allows users to examine different time periods in relation to each other. The raw numbers in each data file can be interpreted as the number of ILI cases per 100,000 population. However, in the U.S., flu activity cases are estimated as ILI cases per 100,000 physician visits. Using the link entitled Animated Flu Trends for Google Earth provides an animation of flu global trends for use with Google Earth. GFT has many strengths. One of these is that GFT appears to be able to track influenza activity faster than traditional surveillance methods. Traditional systems take time to collect, analyze, and distribute data, while Google search queries can be counted immediately and uploaded daily by GFT. This could enable public health officials, clinicians, and government officials to react more quickly to reduce the mortality and morbidity associated with influenza. Hence, GFT takes us even closer to more accurate predictions of influenza outbreaks and true real-time outbreak surveillance. The second strength of GFT is that it provides investigators with large amounts of quality data for longitudinal epidemiological research for a particular region of interest. This infodemiological information can also be used as a foundation to build specialized tools for monitoring other infectious diseases that are appropriate for this type of surveillance. Another strength of GFT is its cost. The analysis of aggregated search queries is considerably less costly than the traditional methods of reporting influenza activity, and GFT is a free service. The fourth strength of GFT is that it estimates that estimates of flu activity are highly correlated with data produced by traditional surveillance. This makes GFT an appropriate supplementary tool for enhancing current surveillance efforts and provides an additional source of biosurveillance information as mandated by HSPD 21. Another strength of GFT is that it could be used as a means of influenza surveillance in countries where other surveillance systems are poorly developed. The use of GFT in this instance should be validated by an established surveillance system associated with a particular country. GFT also has some weaknesses. One of these is the tension between privacy concerns and transparency issues. Google purports that the database used for GFT keeps no information about the identity, IP address, or specific physical location of a user. Additionally, original search logs older than 9 months are rendered anonymous. However, many individuals remain skeptical regarding the level of privacy associated with an individual's information. This skepticism has been further reinforced by recent news reports in which it was revealed that Google may have violated their privacy policy in several situations. Transparency is also an issue, with many investigators unable to obtain original data sets from Google for complementary research. However, it seems that Google is working to provide raw data for further research in the scientific community while addressing privacy concerns. Another weakness is that GFT is best suited to monitor ILI with a high degree of prevalence in developed countries. Thus, GFT is not as an effective surveillance method in less developed countries and areas where ILI prevalence is low. A third weakness is that there are only 4 years of data. Hence, inferential conclusions regarding the analysis of the search engine data may be limited. Another weakness is that a number of searches by individuals may be generated as a result of news reports rather than actual disease activity. This phenomenon could potentially skew GFT results. GFT represents a method of surveillance with the potential to help provide near real-time information to public and clinical healthcare practitioners during the early phases of an outbreak. The data generated from GFT can be used to advance public health care practice, clinical decision-making, and research. Additionally, GFT can be used as a model for the development of other surveillance tools for the monitoring of other infectious diseases on a global scale. GFT is one tool that has a direct application in infodemiology. Metrics and methods developed in other disciplines also have potential applications in infodemiology. Therefore, research partnerships with the private sector, universities, philanthropic organizations, and governmental entities have the potential to develop applications and benefits that will help to improve the ability of biosurveillance to detect and deal with new and emerging threats in a global society, such as bioterrorism and novel infectious diseases. These types of collaborative efforts will generate large data sets that can be analyzed with an ever-increasing level of computational power. This could provide a level of pattern recognition that would provide important information regarding diseases that need further research data, such as Parkinson's and so-called orphan diseases. Terms used in this paper include biosurveillance, infodemiology, and syndromic surveillance.